The e-drive is an electric powertrain. It's typically a combination of the inverter, the motor and the transmission as one functional unit. For this project we're working for a last mile delivery truck. It's a 7.5 ton truck. For every wheel we have a separate e-drive unit. So in fact the manufacturer is using torque vectoring so they can steer and control every wheel independently. For this project we're in fact developing EDUs which are very compact and have a very let's say high power density. And now let's take a look at the assembly line. So the machine you see behind me is the first step of the assembly process. It's called the batch press. So in this step of the process we will press the bearings on the shaft. So we start with the shaft or a gear without bearings. And in this step of the process we will push the bearings on the shaft. So this machine is equipped with servo presses. We monitor the press force so we can assure that for every bearing the press force is in range. The machine is also equipped with a camera monitoring system, so we will check if every bearing and every part which needs to be assembled is assembled in the correct way. For example, if the operator is making a mistake, the machine will just stop the cycle and let the operator correct it to make sure the part is in spec. So we can assure that there is no faulty parts coming from this part of the process. On this part of the machine, we arrive with the shafts with bearings pressed on. But as we use tapered bearings, setting the right preload in transmission is very important. To set the right preload in a transmission, we need to start with measuring the depth of the bearing bores in the housing and the length of the shafts with the bearings. So this is happening on this station. So here the housings are measured, and in these stations we can place a shaft with the bearing races. The shaft is then spun for 50 revolutions to make sure the bearings are settled, and then the length is measured. Based on the length difference between the housing and the shaft, we can calculate the right shim to set the correct preload. We need to set the preload in the range of plus minus 20 microns. To compare, human hair has a thickness of 7 microns, so 20 microns is really an accurate value. Once the preload is determined and the shims are selected, it's time to press the bearing rings into the housing. So this station behind me will pick up the bearings together with the shim and press it in the housing. It's also done with a servo press, so it's also monitoring press force. This machine is also equipped with a servo press, so also here we're measuring the press force of pressing the bearing rings in the housing. The machine is also made in such a way that the operator cannot make mistakes, in the sense that during the preload measurement the bearing rings are locked in the station. They're only released at the moment you can place it in the correct position in the press. So the sequence needs to be respected to make sure that the right bearing ring is ending up with the right shim in the right pocket in the housing. As you can see, in every step of the process we build in the necessary quality control measures to make sure that there is no room for operator errors, and we end up with every transmission being fully in spec and high quality. So once we have the housings with bearing races pressed in and we have the shafts ready, then we come to this station, which is the transmission assembly station. So here we will place the shafts on the station where they can be brought in mesh. So in mesh means that the teeth are contacting each other and the gear set is, let's say, behaving as one unit. Gear set is picked up as one unit, placed in the housing, and then also the sealant is applied and the housing is closed. This step or this part of the process is still relatively manual because we work with relatively low numbers. So to automate this process completely would be relatively expensive and would increase the cost for the customer. So here behind me you see the last step of the assembly process for the EDU. The last step is doing a pressure decay test, so we will, with low air pressure, check if there is any leak in the housing to make sure that the transmission and the seals is fully oil tight. If this test is positive, then the last step we will assemble the electric motor on the transmission. We first have a turning station, so the transmission is assembled with the output side upwards. Then it's flipped to be able to place the input seal. We use barcode scanners here and there to assure part-to-part traceability. So we know which part goes in which transmission, we know the press force belonging to which part. We in fact link all information together. At the end of a build, we also have a full report, a full database with all parameters of every transmission. Like that we can make sure that every transmission is meeting the highest possible quality standards. Once the EDU is completed, we still do a 100% end-of-line inspection to make sure that it's meeting all the VCST quality norms. This is done on this station. We start on this table here, where the EDU is first filled with test oil. So on this station we're filling the test oil for the end-of-line test. We use test oil to make sure that all preserving oil and from gears and bearings is flushed from the transmission during the end-of-line test. Behind me you see the actual end-of-line station. On this station the transmission is tested. We do a certain test sequence where we'll check breakaway torque, drag torque, temperature sensors, other sensors and acceleration and noise and sound levels. to make sure that all parameters of the transmission are within the design specification, and to make sure that the customer is getting, let's say, a high quality standard transmission. For this end-of-line test bench, we developed a software to test the transmission in-house at VCST. This allows us to be both cost effective and tune the software really for the specific needs of the customer. We can really test and simulate what the customer needs, which is more difficult if you go to a commercial system. VCST also has an internal automation department who is supporting the production team with this. Once the end-of-line test is done, the EDU is placed back on the oil fill and drain table. First, oil is drained from the end-of-line test to make sure that all run-in oil and preservatives are gone. So once the oil is drained, we fill the transmission with fresh oil, place the final fill and drain plug and pack the transmission for shipment to the customer.